Now in calculus we come across equations of this type: dy by dx plus py is equal to q, where p and q are functions of x. P and q are strictly functions of variable x. Okay, this is a differential equation. We are supposed to solve this equation to get function y. Here we have a term involving derivative. Okay, that's why this is called differential equation. And definitely if we want to find function y satisfying this equation, then we will be doing something antiderivative. Okay, in fact antiderivative is called integration, an operation opposite to differentiation. Okay, तो हम इसको integrate करेंगे, इसको हम सीखेंगे. We will learn this in differential equation. This is called linear differential equation. इसको कहते हैं हम linear differential equation. Okay, format is this: dy by dx plus p into y is equal to q, where p and q are functions of x. Okay, now to solve this differential equation, what we do, we multiply equation with integrating factor, which helps in integration. And integration factor is defined as e power integration of p with respect to variable x. Okay, now what happens when we multiply this equation with integrating factor? Let me write here, this is integrating factor. Equation will become e power integration of p into dy by dx plus py into integrating factor, okay, is equal to q multiplied by e integrating factor, which is e power integration of p with respect to variable x. Okay, we multiply this equation with integrating factor. Now what is the advantage? We have here y, here we have derivative of y, here we have integrating factor. What will be its derivative? इसका derivative क्या होगा? Derivative of integrating factor will be integrating factor multiplied by derivative of this exponent. क्या होगा इसका derivative? This derivative will be function p, because integration is reverse process of differentiation, or vice versa. Differentiation is reverse process of integration. Okay, so derivative of this will be function p. Okay, so we have here y, here we have its derivative, here we have integrating factor, and here we have derivative of integrating factor. Okay, so basically we have d by dx of y multiplied by integrating factor. Okay, this is how we are able to create this differential coefficient. This is why we multiply with integrating factor. Okay, then we integrate both sides. ठीक है, अब इंटीग्रेट करना आसान रहेगा, because here we created one differential coefficient. Okay, now let's use this concept in some questions of monotonicity. Okay, now we have a question like this: if f of 1 is equal to 0 and derivative of fx with respect to x is greater than function fx for all x greater than or equal to 1, then prove that fx is greater than 0 for all x greater than 1. f of 1 का वैल्यू 0 है, फंक्शन का डेरिवेटिव फंक्शन से ज़्यादा है फॉर ऑल एक्स ग्रेटर देन इक्वल टू 1, तो हमें प्रूव करना है फंक्शन fx जो है वो पॉजिटिव होगा फॉर ऑल एक्स ग्रेटर देन 1. दैट मीन्स ग्राफ ऑफ फंक्शन fx विल लाई अबोव x एक्सिस फॉर x मोर देन 1. Okay, now how can we use the concept which we discussed? अभी जो हमने डिस्कशन किया उसको कैसे यूज कर सकते हैं? Now here in place of equation we have inequality, but the concept will remain the same. What do we do? We take fx on LHS. That means we have now derivative of fx minus fx greater than 0. Okay. Now we compare this with this equation. okay, where p and q are functions of x. Okay, here in place of y we have fx, resemblance hai, okay. The only change is here we have inequality. Okay, now if we compare, what we get p is equal to -1. Okay, p is equal to -1, then integrating factor will be e power integration of -1, and this is e power minus x. Okay, so we will multiply this inequality by e power minus x. E power minus x will be always positive, so there won't be any problem with inequality sign. वो वही रहेगा. Okay, we get e power minus x into dfx by dx minus fx into e power minus x greater than 0. Okay, now this is d by dx of e power minus x multiplied by fx. होगा ना ये? Derivative of e power minus x is minus e power minus x. E power minus x, here we have its derivative, we have your function fx, then here we have its derivative. Okay, so using product rule, this LHS is derivative of e power minus x into fx. Okay, now this is greater than 0. Now this is for all x greater than or equal to 1. So this is derivative of this is greater than 0 for all x greater than or equal to 1. What you can say from monotonicity point of view, derivative of this function is positive. Okay, so this function will be an increasing function. Suppose this is function gx is equal to e power minus x into fx. This is an increasing function for all x greater than or equal to 1. Okay, so we will have gx greater than or equal to g of 1. Okay, x is greater than or equal to 1, and function gx is an increasing function, so we will have g of x greater than or equal to g of 1. Okay, ठीक है, समझ में आ रहा है? So what do you get? Gx is this e power minus x into fx. This is greater than or equal to, what will be g of 1? G of 1 will be e power minus 1 into f of 1, and f of 1 is 0. It's given. Okay, so we get this greater than or equal to 0. Now e power minus x is positive, so from this we get fx greater than or equal to 0 for all x greater than or equal to 1. F of 1 is 0, it's given, so we can say fx is greater than 0 for all x greater than 1. देखो प्रूव हो रहा है, कितना अच्छा क्वेश्चन है. देयर इज अ स्मॉल आइडिया, integrating factor. ठीक है, it's a small idea but very powerful idea. Let's take one more example based on this concept. We're going to look at this question. If h of x naught is 0 for some x is equal to x naught, and derivative of hx is greater than 2cx into hx for all x greater than or equal to x naught, then prove that hx is equal to 0 has no roots for x more than x naught. इस इक्वेशन का कोई भी रियल रूट नहीं होगा फॉर x मोर देन x नॉट अगर h ऑफ x नॉट 0 है, एंड ये डेरिवेटिव 2cx hx से बिगर है फॉर ऑल x ग्रेटर देन और इक्वल टू x नॉट. ओके, दैट मीन्स वी विल बी प्रूविंग दैट graph of hx won't intersect x axis for x greater than x naught. x more than x naught के लिए ग्राफ x एक्सिस को इंटरसेक्ट नहीं करेगा, हम ये प्रूव करेंगे. ठीक है, ओके. नाउ अगेन वी हैव फॉर्मेट ऑफ दिस टाइप dy by dx plus py is equal to q, where p and q are functions of x. Here in place of equation we have inequality. Okay, this term on LHS we get dhx by dx minus 2cx into hx greater than 0. This is for all x greater than or equal to x naught. Okay, now if we compare these two things, we get p is equal to minus 2cx. ये होगा p. Okay, p is function of x, which is minus 2cx. Okay, then integrating factor will be e power integration of minus 2cx. It's simple. Integration of x is x square over 2. 2 gets cancelled, or we get e power minus cx square. This is integrating factor. Okay, so what do we multiply this inequality by this? This is positive. Okay, so inequality sign will remain same. Okay, so we get e power minus cx square integrating factor into derivative of hx minus 2cx hx multiplied by integrating factor e power minus cx square. This is greater than 0. Okay, now what will be advantage? क्या एडवांटेज होगा इससे मल्टीप्लाई करने से? This is derivative of, now this is derivative of hx multiplied by e power minus cx square. Is it? होगा ना ये? Here we have hx, here we have its derivative. Okay, here we have this expression, here we have its derivative. Derivative of this is e power minus cx square into derivative of minus cx square, which is minus 2cx. Okay, so using product rule, this is derivative of this expression. Okay, and this is greater than 0 for all x greater than or equal to x naught. Okay, so what you can say from monotonicity point of view? Monotonicity point of view से हम क्या कह सकते हैं? We can say that this is an increasing function for all x greater than or equal to x naught. Okay, suppose this is function gx is an increasing function. Okay, so for x greater than or equal to x naught, we will have g of x greater than or equal to g of x naught. Okay, what is g of x naught? It will be h of x naught into e power minus c x naught square. H of x naught is 0, it's given. Okay, so this side is 0, and we get e power minus cx square into hx greater than or equal to 0. Okay, this is positive, so we get hx greater than or equal to 0 for all x greater than or equal to x naught. Okay, and x naught is h of x naught is 0. Okay, and function is an increasing function. h of x naught 0 है और function increase कर रहा है, तो graph क्या होगा hx का? What will be graph? Graph will be like this. This is x naught where value of function is 0. Okay, and for x greater than or equal to x naught, gx is an increasing function. तो graph कैसे होगा? Graph will be like this. It will move up. Okay, function increase कर रहा है तो ऊपर की तरफ जाएगा. That means after x naught, graph of hx won't intersect x axis. इस पॉइंट के बाद hx का ग्राफ x एक्सिस को इंटरसेक्ट नहीं करेगा, hx हमेशा पॉजिटिव रहेगा. सो दिस इक्वेशन हैज नो रूट्स फॉर x मोर देन x नॉट. हो गया प्रूव? ठीक है. लेट्स टेक वन मोर क्वेश्चन. ओके, नाउ लुक एट दिस क्वेश्चन व्हिच वाज आस्क्ड इन JEE 2013. JEE में आया क्वेश्चन है तो कुछ तो अच्छा होगा, ध्यान से करना पड़ेगा. Question है, let f from this interval to set R be twice differentiable functions such that f of 0 is equal to f of 1 is equal to 0, and function fx satisfies this inequality. F double dash x minus 2f dash x plus fx greater than or equal to e power x for all x belongs to closed interval 0 to 1. Then prove that. We have your first part. This question was asked in comprehension type. This is its first part. You have to prove that fx is negative for all x belongs to closed interval 0 to 1. क्या करेंगे? Can we make use of this form of equation dy by dx plus p y is equal to q, where p and q are functions of x? हम इसको यूज कर सकते हैं. LHS को आप ध्यान से देखिए. वी हैव टर्म्स कंटेनिंग फर्स्ट डेरिवेटिव एंड सेकेंड डेरिवेटिव. क्या कर सकते हैं? How can we put this in this form? We can split 2 f dash x. We can write it like this: f double dash x minus f dash x, okay, minus inside brackets f dash x minus fx. This is greater than e power x. Okay, लिख सकते हैं इसे. Okay, now we can compare these two expressions. Okay, here we have fx in place of y, then p will be minus 1. Okay, and we can compare this and this. What will be y? Y will be f dash x and p will be minus 1. Okay, this is second derivative. Okay, it is d by dx of f dash x. Okay, so y is f dash x but p is minus 1. Okay, so integrating factor will be e power integration of minus 1. This is e power minus x. Okay, so what do we multiply this inequality both sides by e power minus x. We get d by dx of e power minus x into f dash x. What will be this into e power minus x? It will be derivative of e power minus x into f dash x. Okay, minus d by dx of e power minus x into this will be e power minus x into fx. This is greater than or equal to 1. We are multiplying with e power minus x, so RHS will be 1. Okay, then this will be d by dx of e power minus x into f dash x minus e power minus x into fx. This is greater than or equal to 1. ठीक है यहाँ तक. Okay, now these two terms form derivative of e power minus x into f dash x. Okay, we have now d by dx of e power minus x into fx. This is greater than or equal to 1. Okay, so double derivative of this is greater than or equal to 1 means it is positive. We got double derivative of d square of dx square of e power minus x into fx greater than 0. Double derivative is positive. That means graph of this function will be concave upward. इसका डबल डेरिवेटिव पॉजिटिव है, इसका मतलब क्या हुआ कि इस फंक्शन का जो ग्राफ है उसकी कॉन्केविटी अपवर्ड होगी. ओके, लेट्स ड्रॉ द ग्राफ. Okay, now we got this second derivative of e power minus x into fx is greater than 0. Suppose this is a function gx and we want to draw the graph of gx. Okay, now second derivative is positive, that means graph of gx will be concave upward. Let's draw the graph. We have here coordinate axis. Okay, we have here origin. Okay, and here we mark point having abscissa 1. Okay, now f of 0 is 0, so value of g of 0 will be also 0. G of 0 का value 0 होगा. Okay, f of 1 is 0, so g of 1 will be also 0. So we mark these 2 points which will lie on the graph of gx 0, 0 and 1, 0. Okay, now ग्राफ ऑफ gx इज कॉन्केव अपवर्ड. gx का ग्राफ कॉन्केव अपवर्ड है क्योंकि उसका सेकंड डेरिवेटिव पॉजिटिव है. ओके, सो हाउ विल बी द ग्राफ एट दोस 2 पॉइंट्स? वैल्यू ऑफ gx इज 0 एंड ग्राफ इज कॉन्केव अपवर्ड. ओके, देन ग्राफ मस्ट बी लाइक दिस, है ना. ग्राफ को जिस तरह से होगा जिसकी कॉन्केविटी अपवर्ड है. ग्राफ इज कॉन्केव upward. This is graph of y is equal to gx. Okay, so from the graph we can say that, what you can say about sign of the graph? Function gx will be less than 0 for x belongs to open interval 0 to 1. Okay, gx will be negative for all x belongs to 0 to 1, and gx is e power minus x into fx. This is negative for all x belongs to open interval 0 to 1, so fx will be less than 0 for these values of x. हो गया प्रूफ? तो देखो यहाँ पे कितनी सारी चीज़ें काम आ रही है. फर्स्ट डेरिवेटिव, सेकंड डेरिवेटिव, फॉर्मेट ऑफ लीनियर डिफरेंशियल इक्वेशन, देन कॉन्केविटी कॉन्सेप्ट, ओके, कर्व प्लॉटिंग कॉन्सेप्ट. तो पूरा कैलकुलस यहाँ पे जमा हो रहा है. ठीक है, इसका सेकंड पार्ट करते हैं. लेट्स राइट सेकंड पार्ट. ओके, नाउ हियर वी हैव इट सेकंड पार्ट. If function e power minus x into fx assumes its minimum value at x is equal to 1 upon 4, then prove that f dash x is less than fx for all x belongs to open interval 0 to 1 upon 4. This is graph of function gx. Gx is this e power minus x into fx. Okay. Now function gx assumes its minimum value at x is equal to 1 upon 4. तो यहाँ पे वो पॉइंट कहाँ पे होगा? 1/4 इज पॉइंट ऑफ मिनिमा. दिस इज पॉइंट ऑफ मिनिमा विच इज 1/4. ओके, देन वी हैव टू प्रूव दिस इनइक्वालिटी फॉर ऑल x belongs to open interval 0 to 1/4. It's simple. In the interval, in open interval 0 to 1/4, function gx decreases and then it increases. Okay, function gx decreases for x belongs to 0 to open interval 0 to 1/4, so its derivative will be negative. Okay, derivative of gx is e power minus x into f dash x minus e power minus x into fx. This is less than 0 for these values of x. Okay, so from this we get f dash x minus fx less than 0. We can cancel out e power minus x from both sides. Okay, because it is positive, there will be no change in the sign of inequality. Okay, so from this we get f dash x less than fx for all x belongs to open interval 0 to 1/4. इस रीजन में f dash x less than fx होगा, and in this region for x belongs to 1/4 to 1, f dash x will be more than fx. Okay, तो एक बहुत ही अच्छा क्वेश्चन है इस कॉन्सेप्ट से जेई एग्जाम में.